All right, so if you were here for the last talk, this is actually a great follow-up for that. I'm gonna scare you with how dangerous AI can be. So my name is Claire Weissman. I work for Hidden Layer, which is a startup. We do security for AI, which hopefully will become clear kind of what that is later on in my presentation. So let's begin. All right, so first off, I'm just gonna kind of go over an outline of what I'm gonna talk about today. So first I'm gonna go over what adversarial AI is. Hopefully, as security professionals, you at least have heard this term, but we'll go over it. Some current dangers, what pre-trained models are, some specific AI threats, some alternative options, kind of what existing workflows about using AI and machine learning in companies look like today, what our current state of security is, and moving forward, introducing model scanning, which hopefully you've heard of before, but kind of that as a new level of tooling. So first off, adversarial AI. Adversarial AI is, put in the most simplest of terms, is a type of attack in order to force an AI model to either make a mistake or a misclassification. And so this can be as benign as having an image of a dog be classified as a cat, which doesn't seem all that harmful, to actually having something like a self-driving car not be able to recognize a stop sign. I don't probably need to impress upon you how dangerous that could be, but so you can imagine all of the different issues this could cause, and I'm sure you've seen examples of this in the news, whether or not it was classified as adversarial AI. So first I'm going to go over some of the dangers. Hopefully you've seen some of these examples I'll pull up, and if not, we'll get ready. So this first one is an example of data poisoning. This was actually not intentional data poisoning, but there was a long-running joke on the internet about how Australia didn't actually exist. And Microsoft's Bing, unfortunately, ingested some of this information as training data. And so there was a period of time where if you looked up if Australia exists, according to Bing search results, it did not. Obviously, this is pretty funny. We all know Australia exists, so this isn't all that harmful. But of course, this is relatively damaging to a company that is supposed to be providing, good information as a search engine. The second one is also data poisoning, which was you were able to poison, this attack was poisoning data such that AI assistants or co-pilots and chatbots were able to suggest malicious code. Obviously, there's malicious code on the internet, but ideally, we'd rather not have chatbots helping out with that. This next one is a prompt injection attack. This is ChatGPT. Many of you have probably seen examples of this, but if you ask ChatGPT directly how to make napalm, it will not tell you. But in previous versions of ChatGPT, if you use this type of prompt injection, which was acting the chatbot to act as your grandmother, who was a chemical engineer who used to tell you about napalm, it would tell you how to make napalm. Again, yes, this information is available on the internet, but especially in terms of company ethics and values, this is not really something you would want something embedded in your company to be able to tell someone. And a lot of chatbots that you see on the internet today their backend is using ChatGPT. And this last one is, if you're in the security space, you probably know about this attack. It was named Silence, I Kill You. It happened in 2019. Very close to home for the company I work for. It actually was the precipice of our startup. It was a model evasion attack. Cylance was using AI to actually secure other things, which is AI security, slightly different. But a threat actor was able to re-engineer some API endpoints and was able to completely bypass the model at the end of their attack. And this attack was going on for, I want to say it was like 60 to 90 days, and it was not known about until it was published that they had attacked Cylance. Obviously, this was extremely serious. And again, this happened in 2019. So these threats have become very on the forefront recently, but this has been happening for quite a while. And lastly, one of the even more fun dangers is not only is our AI very vulnerable, AI is also being used as another tool for threat actors. And obviously, if you're a company and you have a chatbot or you're supporting a chatbot, you don't actually really want it to be used to help attack yourself. So, Microsoft and OpenAI were presenting about, or wrote an article about that, so you can continue to see that as well. All right, so hopefully you all know why this matters, but if you're not as much in the AI space, you might see ChatGPT as kind of a fun thing to interact with, but not a super serious thing to be in production and things like that. It's, fun to ask questions too, but am I really, using it for massive parts of my job? All right, so by 2026, more than 80% of enterprises will have used generative artificial intelligence application programming interfaces, models, or deployed GenAI-enabled applications in production environments, up from less than 5% in 2023. So obviously we're in 2024 at this point, so we're at higher than 5%. And this is just talking about GenAI, so that's when you think of things like LLMs, chatbots, copilots. This is not talking about lower level machine learning models as well. And so currently right now, most companies have about 1,500 machine learning models in production in their company. And through the work with partners and talking with a lot of people in the space we've been in, it's actually found out that a lot of companies don't know how many machine learning models they have deployed, which is obviously very concerning. How are you supposed to protect something if you don't even know where it is or if you have it? Come on, there we go. So now I want to talk about pre-trained models. So everyone probably knows kind of what a chatbot is in general, but when you're interacting with a machine learning model or an AI model, you're interacting with a pre-trained model. So it's already been fine-tuned, it's already been trained on usually a massive data set for a specific task. For instance, ChatGPT, the specific task is to respond to your questions and to produce the best output based on what the input was. So what is the threat with that? I mean, we've heard about prompt injections from the previous speaker. I'll talk a little bit about that. But the threat is actually much larger than that. So machine learning models are often serialized, which is very easy to hide malicious code in serializations. This is not a new machine learning problem. This is something we've known about, but it's come up again. Given what I talked about with pre-trained models, they're often huge. And so whether you're passing them in between people at your company or they're being uploaded to places like Hugging Face, which is a model repository, they're usually serialized because they're just unmanageably large. Each AI or ML framework has its own unique vulnerabilities. We have things like serialization vulnerabilities that kind of apply across the board, but each individual framework has its own method of doing things and then their own issues. So there's no one solution fits all. And at the end of the day, I probably don't need to tell you all this, but AI and ML models are code. So any vulnerabilities that you can expect when you're just doing a regular program apply to machine learning models, which I think is sometimes lost when you're interacting with something past production. All right, so I want to talk about some specific model threats. So here I'm going to talk about 3 very popular machine learning frameworks in Python. So first off, Keras, and all of these are great frameworks if you want to research them some more. Keras allows for code execution in Lambda layers. So Lambda layers are this special feature that Keras allows, so you can add bespoke expressions to your machine learning model to specifically tailor them. This is a feature of Keras that they have intentionally implemented for that methodology. Unfortunately though, arbitrary expressions allows for arbitrary code execution as well. And in the way that these layers are serialized, it's harder to catch. TensorFlow allows for exfiltration, code execution, and directory traversal in the way that they store their tensors. And PyTorch allows for code execution. And like I said, again, these are not esoteric libraries that data scientists are tinkering with on their own. These are the main frameworks that if you find a machine learning model, it's probably in one of these 3. And if you go on Hugging Face, most of them are in one of these 3. So now I want to talk about pickle serialization. So probably all of you have heard about pickle serialization. It's a very, very common serialization method in Python. So is pickle serialization safe? So I asked this question to ChatGPT. I was curious what it would say. And pretty much resounding, the answer is no. So not only is, serialization has its issues. The way that Pickle serializes files, it's possible to inject code that will be executed upon deserializing or unpickling is their term, the file. So that doesn't even start to talk about, is the file itself dangerous? Just trying to unpickle it before you can even look at it, you're opening yourself up to pretty serious vulnerabilities. If you go and look at the official Pickle documentation on Python, they also tell you this. They tell you, don't open Pickle files if you don't know where they've been, things like that. Obviously, this is, that's green fields. We would all love to always know the origin of every file we open, but unfortunately, especially with data files, this is not always completely possible. So, I've hopefully scared you a little bit. So are there alternative options to these issues? And, well, a little bit. So in response to security concerns, Hugging Face, which is a huge model repository, created a new format called SafeTensor. And this was very exciting for anyone in the machine learning world. Hugging Face is really the main player on the stage for storing machine learning models. If you go on there, you can find ChatGPT, you can find Llama. All of these main things are stored there. And just like GitHub, individual contributors have their own things, their own spin on things, all of that. So Hugging Face implemented an ability to convert current PyTorch tensors to SafeTensor format on their website. So you didn't have to, download a new library, redo the saving of your model, anything like that. So this sounds great, ease for everyone involved, in theory. Unfortunately, that was not so much. The converter and service bot that Hugging Face implemented was actually able to be hijacked. So you were able to upload a machine learning model with some certain malicious code that was able to impersonate the service bot and create pull requests for any model on Hugging Face with malicious code in these pull requests. Obviously, the person who owned the model would need to accept these pull requests, but all of these files are serialized, so if you were to look at the diffs of the two files in the pull requests, you would not be able to tell that it was malicious code. And given that it was a service bot from Hugging Face, you're more likely to trust it and accept the pull request, given that it would have probably been labeled something like SafeTensor's update, SafeTensor's patch, anything like that. So that's pretty concerning and an unfortunate reality to, there is not a one fix. And this was also only a solution for PyTorch tensors. This wasn't a solution to any of the other formats out there. So now I want to talk a little bit about, what are some of our existing workflows with machine learning. So I'm just curious, how many people here have actually coded a machine learning model or seen the code of a machine learning model? Okay, right. So it's not that many people. This is not something that's super prevalent in the security space right now. I mean, securing them is for sure. But so kind of the common existing workflows is these are things being deployed by data scientists and software engineers. And before this happens, it's kind of a manner of things. Maybe you're making the model completely from scratch by yourself, but probably not. You're probably using resources on the internet. You're potentially even downloading a model from Hugging Face, which is very understandable. Why break or try to fix models when there's already really good ones out there? So generally, they're uploaded to potentially a vulnerable server with very little authentication. And lastly, AI is just being used in general by employees to automate work, whether this is you have to write an email to your boss and you want to sound a little bit more official, so you plug it into ChatGPT, or you're using GitHub Copilot to help suggest code for you. And for those of you who use GitHub Copilot, how much do you read the lines it suggests? Maybe you see that they're trash and you throw them away, but are you line by line, expression by expression checking what you're coding? Probably not. I'm certainly not. And I'm in this security space. So, and this is the last bullet point especially, this is kind of unchecked. Companies might be putting out things like, please don't use ChatGPT, it's against our company policies, but in the reality, it's happening everywhere. It's in our emails, it's in social media, it's in browsers, it's on your bank website, in your chat bot. We can't get away from it. All right, so what's our current state of security? So most current cybersecurity solutions are not specific for machine learning. This is hopefully not news to anybody, but so there are a lot of great cybersecurity solutions out here for protecting all manner of things in the tech space. And there are certain machine learning attacks that potentially could be caught through this, but it's not a complete fix-all. There's specific parts of code, specific attacks that we don't protect against. There are a lot of organizations like MITRE ATLAS or OWASP that are specifically focused on identifying attacks rather than preventing. While this is extremely important, it's not as important to know what the attack was after it happened. I think we would all much rather have prevented it in the first place and know where the vulnerabilities are before threat actors found them. And as a general statement, this is not true across the board, but machine learning models are neither checked before entering a company workflow or routinely checked once they've entered company usage. So this is also a big one of, this is kind of a multi-pronged problem. Not only are we dealing with the issue of there could be vulnerabilities in your original machine learning code, there could be malware in your original machine learning code, there can be malware in your data, but you might put up a completely safe model at the time, and over time, through data poisoning or through intentional malware attacks, your model is no longer safe. And there is really just kind of a lack of checking in that sense. So hopefully I scared you slightly or a lot. So what does that mean for moving forward? What does that mean about changing the space? I mean, we've heard all about how much AI is changing. We've heard specifically from the Biden administration about handing down specific securities, but how do we actually implement that? There aren't specific tools or a plethora of specific tools. So model scanning at every level. And obviously this is not a simple solution. I talked about with each framework has individual things, and even just typing machine learning files is not a simple problem. But there needs to be model scanning at every level, specific byte-specific scanning. All right, so this is kind of the proposed idea is, so in terms of when you're designing a model, there needs to be direct communication and documentation about what is the provenance of this model, is it made completely in-house, what libraries are being used, everything with that, and a conscious awareness of security vulnerabilities in these models. What we talked about with the vulnerabilities in TensorFlow and Keras and PyTorch, a lot of these vulnerabilities come from specific features that these models have. So you can't just, blanket across, I'm just not going to use any code that has any known vulnerabilities. It's probably not possible. And these are just the vulnerabilities we know right now. So in pre-deployment, again, scanning again. Anytime this model changes hands, it's being scanned. The data is being scanned. And lastly, post-deployment, a continuous scanning of this model and also a monitoring of what is happening with this model. So who has access to this model, who is inputting to this model, and where is this model living within the company workspace. If you've seen any fun prompt injection attacks on like chatbots on bank websites, oftentimes these chatbots, they're maybe there just to help you get to the right person in the company to ask for help, but they often can spit out information like their training data, their executives, potential account information. So even if you haven't given specific information or you've put guardrails on things like chatbots, they potentially have access to more information than you realize. All right, so again, hopefully I scared you a little bit and educated you on kind of what machine learning and AI look like in the security space. Yeah, does anyone have any questions? Way over in the back.
What does it mean to scan a model? Is it like static analysis of code like do a SEMGRET?
Yeah, exactly. Sorry, I should have mentioned that. But so, yeah, scanning a model, like I said with pickle serialization, obviously this needs to be some sort of static analysis. You can't open it. So basically it needs to be like a byte by byte scan. So we can fully understand what's in this model, but we can't open it before we have any understanding of that.
So essentially it would be like a black box analysis of that pickle file, like the serialization of the model?
Yeah, exactly. So, yeah.
Pickle isn't safe. Is there an alternative that is?
No, there is not an alternative that is safe. That is, there are some other serialization options, but all of them just have different problems. HD or HDFS is another serialization. Onyx allows you to save your models in a slightly different way, but at the end of the day, no, there is not a solution.
What gives the scan the context to determine whether it's a good file or a bad?
Yeah, so at least for the case for my company, we have specific malware that we have identified as unsafe. So there's kind of different levels. There's specific malware that we are looking for, whether that's certain libraries or certain code. And then there's also just general things we're looking for that we know are easy to exploit. So there's kind of the two levels of your model is unsafe, it's been attacked, and your model has security vulnerabilities. And that's all through like specific research that we've done that we've found.
Inside the model before that you can obfuscate the data so that when you're scanning it before you deserialize it, that you can't do the detection?
We haven't run into issues with that specifically. Do you mean that it would be obfuscated in a way that we wouldn't be able to detect something was unsafe?
Yeah, because you're scanning the serialized data, right? And so like if it's obfuscated in a way that once it's deserialized, right, and the malicious content is there, but you're scanning it when it's serialized, so you may not see it.
We haven't come across that with the way we're, I don't want to say opening pickle files because that's not the correct term, but we are doing a static scan of the deserialized data.
Are there safer ways to deserialize information? Like certain context?
Probably the best answer would be open your files in a sandbox. Don't open them on your own computer. But again, no, not in general, not really. All right. Well, thank you all so much.